Hello everyone, how are you? I am Manoj sir from AP. Today I will discuss number system part 3. Yes students? And today our points of discussion are concept of irrational numbers, first point. Second point, basic 4 operations on a rational number and irrational number. Third point, to prove root n as an irrational number where n is any non-perfect square integer. Yes, non-perfect square integer. Now, fourth point, we have to prove a plus root b as an irrational number where a is any integer whereas b is non-perfect square integer. And fifth point, the square root spiral and representation of an irrational number on a number line. So these 5 points I will discuss one by one. Please see the now first point, concept of irrational numbers. Already we have learned what is rational number. A rational number that can be expressed in the form of p by q, whereas irrational number which cannot be expressed in the form of p by q, where p and q are integers and q not equals to 0. Is it clear? But if we solve one equation, say x square equal to 2, and if I ask what will be the values of x, then what will write? X equals to plus minus root over 2. Yes. So this root over 2 you did not see in the rational number system. Root over 2 cannot be expressed in the form of p by q, where p and q integers and q not equals to. Yes or no? So root 2, this is one irrational number. So in general, square root of any non-perfect square integer is irrational number. So root 3, root 5, root 6, all these are irrational number. But not only the square root, if we take cube root, say cube root of 2, cube root of 3, these are also irrational numbers. Yes or no? Now if we take one rational number and one irrational number, so this is binomial irrational number, so 2 plus root 3, it is also one irrational number. Yes or no? Now pi is also one irrational number, e also one irrational number. And what is the value of pi? If I considered the decimal representation of pi, and we know in decimal representation of irrational number what? Non-terminating and non-repeating. Yes or no? So that means pi value 3.14 1 5 9 2 and 6 and dot dot dot. See, I wrote the value of pi up to 7 decimal places. So how can I remember these results up to 7 decimal places? This is very easy method to remember it. What is it? See, just remember it. May I have a large container of coffee. If you remember this sentence, may I have a large container of coffee, then you can write the value of pi up to 7 decimal places. Check it. May means 3 letters. 3 point I means 1 have 4 A means 1, large means 5 letters, container means 9 letters, of 2 letters, and coffee 6 letters. So easily we can remember up to 7 decimal places the value of pi. Is it clear? Similarly, the value of E also we can remember. If you remember this sentence, what? We planned a planning to remember a solution. We planned a planning to remember a solution. If we know this sentence, then easily we can write down the value of E. How? We means 2 letters, so 2 point planned means count 7 letters, 3, 5 to 7 letters. So 7, yes, 7 letters coming. One, A means 1. So this is 7, 2.71, planning, count 8 letters, 2, TO2, 2 letters, remember, again 8 letters, 1, and solution, again 8 letters. So like this, 2.718218. So that means here also 7 places we can remember the value of E. I think this part is clear. So concept of irrational numbers, what we got? The square root of any non-perfect square integer. If you cube root of any number which will not give rational number, these are also irrational number. Yes or no? So now I'll discuss the second point, that is basic 4 operations on a rational number and an irrational number. So first point, concept of irrational numbers completed. Now I am going to discuss the second point, basic 4 operations on a rational number and irrational number. What are these? The sum or difference of a rational number and irrational number is always irrational. So if I take one rational number, say 3, and one irrational number, say root 7, and if I add them, 3 plus root 7, it is irrational number. Similarly, say 5 minus root 3. 5 is rational number and root 3 is irrational number. So 5 minus root 3, the whole thing also irrational number. Yes. Now come to this product or quotient of a non-zero rational number and irrational number. That is also always irrational number. For example, if I take 4 and rational number and root 7 irrational number, then 4 into root 7, that is 4 root 7, that is irrational number. Yes. Now say root 3 irrational number, and if we divide by a rational number, say 4, so root 3 by 4, it is irrational number. I think this part is clear. So basic 4 operation means addition, subtraction, multiplication and division on a rational number and irrational number. I think this part is clear. So now I'll discuss my third point. To prove root n as irrational number where n is not perfect square and not perfect square integer. Yes or no? So third point, how can we prove root n as irrational number where n is not perfect square integer? Clear? So we can prove in different ways, but here I will show one method which is totally different, which are given in different books. It is totally unique method from others. What is the method? The first we will assume root n as a rational number. And since we are assuming it is a rational number, so it can be expressed in the form of p by q. And if I consider p by q in the lowest form, q not equals to 0 and p and q will be co-prime integers. Yes or no? Now squaring both sides, what we are getting? N equal to p square by q square. Yes? Now we will consider two cases. Since q is integer and q not equals to 0, so q can be 1 or q cannot be 1. Two cases. So first we will consider q is 1. When q is 1, then n is coming p square. So that implies n is perfect square, which contradicts the fact that n is not perfect square. Yes or no? So that means our contradiction is wrong. Our assumption is wrong. Yes? Now case 2, when q not equals to 1, when q is not 1, then n equal to p square by q square. It is not an integer. Why not an integer? Because p and q are co-prime. Since p and q are co-prime, so p square is not divisible by q square. Yes or no? P square is not divisible by q square. That implies n is not integer. But we know n is not perfect square integer. So here also we are getting contradiction. And due to this contradiction, we can say our assumption is wrong. So combining two cases, we can say that what will assume root n as a rational number, that is wrong. Hence root n is an irrational number. Is it clear? So it will be more clear if I take one example. So example 1. Prove that root 3 is an irrational number. So to prove this as an irrational number, first we have to assume it is a rational number. Let us assume that root 3 is a rational number yes therefore we can write root 3 equals to p by q where q not equals to 0 yes and p and q are co-prime integers. Co-prime integers meaning they have no common factor other than 1. Yes? So squaring both sides, 3 equal to p square upon q square. We are getting this result. Now case 1, q equals to 1. Then we are getting 3 equal to p square. What implies it? 3 is a perfect square. This implies 3 is perfect square. But it is not true. Therefore, our assumption is wrong. Now let us see case 2. Q not equals to 1. When Q not equals to 1, then we are getting 3 equal to P square by Q square. Since P and Q are co-prime integers, they have no common factor other than 1. So P square is not divisible by Q square. Yes or no? And P square is not divisible by Q square means this P square by Q square is not an integer. This implies 3 is not an integer because P square by Q square is not integer, as P and Q are co-prime. Yes, is not integer. So P and Q are co-prime, that's why P square by Q square not integer, and that implies 3 is not integer. But it is wrong. But it is wrong because 3 is integer. We know 3 is an integer. So that means from two cases we can say, from two cases we can say our assumption is wrong. Since our assumption is wrong, so we can say root 3 is an irrational number. Yes or no? So I think this part is clear. Now take one more example. Say root 6 we have to prove as an irrational number. Root 3 was the prime number, but 6 is not prime number, but it is non-perfect square integer. So similarly, like previous example, we can prove it is an irrational number, and for that we have to consider, or you have to assume root 6 as rational numbers. So let us assume that root 6 is a rational number. Therefore root 6 equals to P upon Q, where Q not equals to 0, and P and Q are co-prime integers. Yes. Now squaring both sides, we are getting 6 equal to P square upon Q square. Now we'll consider case 1. Q equals to 1. When Q equals to 1, then we are getting 6 equal to P square. This implies 6 is perfect square. Which is completely wrong, which is not correct. Yes. Now case 2, q not equals to 1. So in this case we are getting 6 equal to p square upon q square. So from here what you are getting? 6 is the integer value, whereas p square by q square is non-integer value. 6 is equating with a non-integer value. Because p square by q square is non-integer, as p and q are co-prime. Yes or no? Since p and q are co-prime, that's why p square by q square is non-integer value, but this side is 6 integer value. So 6 is equating with a non-integer value because p square by q square is non-integer, as p, q are co-prime. But it is not true. One integer value cannot be equal to the one non-integer value. So which is wrong? So combining two cases, we can say our assumption is wrong. Since our assumption is wrong, so root 6 we can say as an irrational number. Yes, this part is clear. Now I'll discuss this point to prove a plus root b as irrational number where a is any integer but b is non-perfect square integer. A plus root b, that means one rational number and one irrational number. So how will prove this kind of number as an irrational number? That I will show you. So fourth point I am going to discuss now. So here also first we have to assume the a plus root b as a rational number, and a plus root b equal to p I have taken, where p is a non-zero rational number. But see here I am not taken p by q form because we are assuming this is a rational number and p we are considering as a non-zero rational number. Yes or no? Then root b equal to p minus a. So root b, left hand side root b is an irrational number, whereas the right hand side p minus a is a rational number. So one irrational number cannot be equal to a rational number. Yes or no? So that implies our assumption is wrong. Or when assumption is wrong, and from that point we can say the given number is an irrational number. So like this we can prove. This part is clear? Now it will be more clear if I take one example. We have to prove 5 plus root 7 is an irrational number. So how will prove it? First we will consider it is a rational number. So let us assume that 5 plus root 7 is a rational number. and we'll consider it is non-zero rational number, obviously, because root 5 plus root 7 cannot be 0. So that's why it is a rational number, obviously non-zero. So 5 plus root 7 equals to p. I have not taken p by q, that's p, because we are assuming it is a rational number, so we can denote a rational number by p only. P denotes the rational number. Yes or no? So this implies root 7 equal to p minus 5. So from here, what we are observing, left hand side is irrational number. Left hand side root 7, which is irrational number. Whereas right hand side p minus 5, which is rational. Why rational? Because p is rational according to our assumption, and 5 already we know it is a rational number, and difference between two rational number is obviously rational number. So right hand side is rational number. So that implies irrational number equal to rational number. Impossible. So left hand side cannot be equal to RHS. Therefore, our assumption is incorrect. Hence, 5 plus root 7 is an irrational number. Yes, we can prove like this. Now, one more example. Prove that 6 root over 13 is an irrational number. So here the number is what? Product of a rational number and irrational number. So how will prove this kind of sum? So here also we will assume, let us assume that 6 root 13 is a non-zero rational number. Yes. Therefore 6 root 13 equal to p, where p is non-zero rational number. Yes or no? So this implies root 13 equal to p upon 6. So here also we are observing LHS root 13 is irrational. It is an irrational number. Whereas RHS p upon 6 is rational. Because p is non-zero rational, we consider, and 6 rational number. So p upon 6 is also rational. So here also LHS not equals to RHS. Is it clear? Pi plus root 7 equal to p. P was rational number because we consider this. So it will be better if I mention here p is non-zero rational number. Similarly here also we'll mention p is non-zero rational number. Yes. So left hand side not equals to RHS. This implies our assumption is wrong. Since our assumption is wrong, we can say hence 6 root 13 is an irrational number. Clear? Now example number 5. We have to prove root 17 by 4 is an irrational number. So here one irrational number is divided by irrational number. First we considered it is a rational number. So let us consider that root 17 by 4 is a non-zero rational number. Therefore root 17 upon 4 equals to P. P is non-zero rational number. Clear? Now root 17 is 4p. So like previous case, again we are getting LHS irrational, whereas RHS is rational. Therefore LHS not equals to RHS. Yes? Here also you are getting LHS is not equal to RHS because one irrational number cannot be equal to a rational number. So this implies our assumption is wrong. Hence we can say root 17 upon 4 is an irrational number. I think this part is clear. Now I'll discuss my last point, the square root spiral and representation of an irrational number on a number line. This is my last point. The square root spiral and representation of an irrational number on a number line I'll discuss now. See here, it is the square root spiral. How it is formed? How this spiral is formed? First, one right angle triangle having two legs, 1 unit and 1 unit. Yes, one right angle triangle having two legs, 1 unit and 1 unit. So if you apply the Pythagorean theorem, then what is the hypotenuse value? Root over 1 square plus 1 square, that is root over 2. This hypotenuse value length is root over 2. Now again on this diagonal at this point again we have to consider one right angle triangle whose two legs are root 2 and 1. And if you apply Pythagoras theorem on this triangle, then hypotenuse we are getting root over 2 square plus 1 square, that is root over 3. That means this hypotenuse is root over 3. So like this, if you continue like this, the next diagonal will next hypotenuse will be root over 4, that is 2. Next hypotenuse will be root over 5. Next hypotenuse will be root over 6, like this. Is it clear? So like this this spiral will be formed. Is it clear? Now, representation of an irrational number on a number line. See this picture? Here, root 2, root 3, these two irrational numbers are represented on a number line. How? So on this real number line, this is 0 and this is 1 and this is A point and this is P point and here Q point. So first what? From origin to A is 1 unit, and at A this perpendicular length, that is AC, is 1 unit. So if you apply the Pythagoras theorem on this right angle triangle, then we are getting this hypotenuse is root 2. Now taking OC as radius, if we draw a circular arc that will meet at on this number line at P, then OP, that is root 2. This length OP will represent root 2. So P point is the representation of root 2. P point is the representation of root 2. Is it clear? Now Q. Q represents root 3. How? OD is root 3. Because OP just now here root 2 and it is 1. So this leg is root 2, this is 1. So again applying Pythagoras theorem, this hypotenuse we are getting root 3. Root 2 square, that is 2 plus 1 square 1. This is root over 3. That is OD is root over 3. Now taking O as center and OD as radius, if we draw a circular arc, this circular arc will meet the number line at Q. So OQ represents root 3. Is it clear? So Q is the representation of irrational number root 3. So like this we can represent one irrational number on a number line. I think this part is clear. Now I am taking one example. Represent root 5 on a number line. I will show two methods. Method 1, first I will draw one number line. We will mark this point as origin. Now root 5 is 2 square plus 1 square, 4 plus 1 5, yes or no? So 5 is expressed as the sum of two squares, that is 2 square plus 1 square. So from that point we will mark, suppose this is 1 and this is 2 and this is 3 and this is 4, like this. So at 2 we will draw one perpendicular line and we will consider 1 unit from this perpendicular line. We will consider 1 unit. So this is 1 unit. So if I mark this as A, OA is 2 unit, and if I mark this as B, AB is 1 unit. Now if we join OB, this will be the hypotenuse of the right angle triangle OAB. Then what will be the length OB? Applying Pythagoras theorem we are getting root over 5, yes or no? Root over of 2 square plus 1 square, root over 5. Now taking OB as radius and O as center, if I draw one circular arc, that circular arc will meet the number line in between 2 and 3 at some point, and this point will represent root over 5. Yes, this point will represent root over 5. So this is method 1. Now method 2. Here also will represent root 5 on a number line. But here I am expressing this 5 as the product of two numbers, that is 5 into 1. So any number under root, say decimal, non-perfect square, any number, any irrational number, we can represent by method 2. How? The number into 1. We'll express any number into 1. So here 5 into 1. Now say, we'll draw one number line and we'll mark origin. Now say this is 1, this is 2, this is 3, this is 4, like this. And this side, left side of origin, say minus 1, minus 2, minus 3, minus 4 and minus 5. So clear? So now from origin to this part is 5 unit. 1, 2, 3, 4, 5. So suppose this point A point. And 1 from origin to this is 1 unit. So I am marking this as B unit, B point. So what is the length of AB here? 5 plus 1, 6. AB length here 6. Now divide by AB, that is 3. Half of AB, that is 3. So at 3, that means from origin 1, 2, 1, 2, 3. That means this is the center point. Yes or no? So marking C as the center, because from C left side 3 units and on the right side also 3 units. Now taking C as center and 3 units as radius, if I draw a semicircular arc, it will be like this. Yes. Now at origin we'll draw a perpendicular line which will meet the semicircular arc at a point, say P point. Yes. Now what will be the length of OP? What will be the length of OP? How will measure it? Now from center to P point, if I join CP, it is right angle triangle. So OC, that means from origin to C point is 2 unit. And this is 3 unit because radius is 3. So it is 2 unit and it is 3 units. So root over of 9 minus 4. If you apply the Pythagoras theorem, square root of 9 minus 4, that is square root of 5. That is the value of OP. So now taking O as center and OP as radius, if I draw a semicircular arc that will meet the number line at a point, and that point should be in between 2 and 3 here, and this point is the representation of irrational number root 5. It's clear? This point is the representation of irrational number root 5. I think this part is clear, method 2. Yes, I am ending my class here. I think you have enjoyed this class. Still, if you have any problem, you can contact me through my mail ID manojj@tijps.in. Have a nice day. Thank you, students, and don't forget to see my next video to get more interesting sums. Thank you, students.